Welcome to the last chapter in this lecture about information technology. This is about IT and ethics. So far we have focused more on technical issues, but finally we should not leave away the impact IT has on society and which brings us to some ethical questions. We already touched this issue very briefly in the first lecture about digital transformation. You remember we have 4 classes of challenges which are dedicated to technology, to organization, to value added, and the last one is compliance. And here we find things like legal issues. We find things, for example, like co-determination. You cannot simply start with a new IT system without asking your employees, at least not in Germany. You have some compliance rules, for example, within finance industries. You have data privacy issues. At least since we have GDPR, they are more and more clarified. However, there are ethical issues which are going beyond what is defined in legal issues. What are ethical issues? For example, you would like to have software which is fair, which does not favor some parts over others. For example, a software should include all parts of the society. It should not favor male over female or white people over people of color, but actually this is what currently is happening. And the question is, how can you work against this kind of trend? To discuss ethical issues with respect to IT is something which has not been done very often and is an issue only in the last years. So I won't come up with a recipe how to do it. I would only like to focus on issues we face, on problems we have found in the past years, and I would like to point out that there are approaches which try to work against these ethical problems. It's not more than that, but it will become an issue. It will become have more impact in the future, so you should be aware. We talked about artificial intelligence and the training of neural networks in the last chapter. Sometimes not the artificial intelligence is a problem, however the training data is. If you take historical data and the data has been proven to have at least a racist flavor, then the result will simply be racist as well. Here is a case with the health industry in the US. Millions of health records have been taken to train systems and see to what kind of decision should be made when it comes to curing ill people. As in the past, people of color did not get the same level of health and medicines, the machine algorithms learned that people of color have to be treated differently, not as well as white people. In the end, the system is behaving racial. That's definitely not okay. The question is if now maybe the system should be used only for white people. But is this a discrimination of the people of color? These are very severe questions you have to answer. Take another example, but going into the similar direction. Amazon every day gets thousands of applications. And of course, they would like to use AI to make a first filter mechanism to just get those people who might be good people and who might be of interest for Amazon. What's it done? They trained a neural network with all the old applications and the decision who has been recruited and for what kind of position. And actually in the past, male have been favored over female. Probably not consciously, but it has been done. So what happens? The new recommendation software favors male people over female people. So if you're female and applying for a job at Amazon, you have had worse chance because you're filtered out by the algorithm, at least if it's going for senior positions. Now you see Amazon has scrapped their recruiting tool after a while because simply they did not have the data to feed this algorithm, to train the algorithm in the right way. So the problem is sometimes not the IT, but the historical data we have. If this data is in a way unethical, if it is full of racism, or if it is not gender neutral, or if it favors elderly over young people, you will face a problem. You will get systems which do not work fairly. There's other issues. Yeah? When you look on the last year during the corona pandemic, then we have worked many times at home. Working at home means you have to work through video conferences, you have to use the central servers, you have to access the data in there. And this can be very well surveyed by the company. And of course, this has been done. Of course, you could always argue, we would just like to check who is doing well, we would like to take care for our employees, and so on and so on. But it can very easily turn into another direction that you do, let's say, some kind of performance measuring to support only the good ones and to fire the bad ones. Even if you look on toys, yeah, you can see that surveillance is possible in here. So nowadays, these teddy bears and puppets sometimes do use artificial intelligence. They are connected to the internet and can be used for surveillance as well. Is this something we do really want? If you just discuss a technical perspective, it's fine, we can handle these things. If you look on the value added, yes, you can gain some money, but do we really want it? Do we want it as a society? Do we want it as an individual? Can we, as an individual, in comparison to a company, fight against it? These are crucial questions, and we have to not hide away from these questions, but as a society, we have to answer those. We have to deal with those questions. Two more examples. Yeah? Not only through the COVID lockdowns, but simply by social networks, and in the past 20 years, we know this term hate speech. Yeah, you know how people behave in the internet, how they do react in Twitter, Instagram and co, what kind of nasty comments and mobbing is taking place. Is this the world we have created, or did we want to create this kind of communication in the world? What can we do against this? These are maybe not things which are on a legal level. They are more on an ethical level where we have to organize and find out what do we want to go for, even if no legal things are broken. What are the root causes of these trends, of these problems we are facing nowadays? One, of course, is we do have more powerful IT. And this more powerful IT enables us to do more and more things. Just think about again these neural networks which have to be fed with millions of pictures. In the past, we simply did not have these pictures, at least not in a digital way, and it would have been really a big effort to get these pictures digitized and fed into a neural network. Nowadays, There are a million photos, billions of photos in Instagram. You can simply grab them and use it for steering your artificial intelligence. Or there has been a company which simply has fetched billions of photos of faces and is now selling these for training neural networks. So simply having the power, simply having a more powerful IT enables us to do more things. And you know the background, Moore's law. You remember this exponential growth, which led to more powerful computers and bigger memory. And we're not talking only about the memory of a single computer. We're talking about the worldwide amount of data. You can see it here. This has gone up in the past years. It will go further up in the coming years. So what we're talking here are zettabytes. By the way, do you know what a zettabyte is? If you know what a terabyte is, then the next is exabyte, then comes petabyte, and then it's zettabyte. So zettabyte is roughly 1 billion terabyte, which is 1 billion kilobyte, which is 1,000 times a billion byte, which is really a big amount of data. And you see the trend, it's going up. And you simply need this kind of amount of data to train neural networks. More powerful IT enables us to not only have faster computer, but we have made big advances in data analytics, especially in artificial intelligence and machine learning. This was only possible due to the fact that we have powerful computer and powerful and a big amount of data. But here we have learned in the past years how to do the training, how to configure these kind of algorithms, and so on and so on. We do have millions of mobile devices, not only smartphones, but for example cameras and sensors in cars and so on and so on. Number of sensors is increasing, and the networking between the computers and these mobile devices is increasing as well. We talked about convergence of networks. So we have a power network, we have a TV network, we have a telephone network, and we have a computer network, but these are becoming more and more simply one big network. And last but not least, we have an integration of the virtual and the real world. Meanwhile, computers are no longer only in a PC, but there are parts of a washing machine, of the coffee machine, of a car, and so on and so on. And having these kind of embedded machines, computer embedded in physical machines, then this gives much more possibilities. This enables us to do more and more things. Another root cause, our belief in progress. Data is knowledge, data is money, data is power. And there will always be people who try to create added value for themselves or for the society. And that's not bad in the first place. It's what is the engine for progress. Without this kind of gear, we would still live probably in a Stone Age. Often the quality of the IT system is not questioned. We simply believe what they are telling us. Take this example again from the navigational system in the car. However, it's very important to understand what data was used to train a system, because based on this data, the behavior of the actual system is grounded. If a decision was made by a computer, the result is not questioned any further. So if I do get a feedback from the computer, hey, you do not get the credit, and probably the computer is not able to argue what is really the reason for not getting a credit. See, the people in the bank even if he has to, is not able to override this decision. And to many users, it is not clear that a decision is at least partially influenced by arbitrary parameters chosen when doing the training. When it comes to these arbitrary decisions or arbitrary configuration of neural networks, let's take the following simplified example. Actually, this is going back to a real example in the US. The problem, the background is, in the US many people are sitting in prison. And the question sometimes is, who should be released from prison ahead of schedule? And in our case, we have two attributes. Of course, there is much more attributes which you could look at. First, we have our so-called regret factor, which is an arbitrarily defined factor, and we have a malice gain. Yeah, and you can see we have two types of people in here. We have the red ones, historically, we have historical data, and now this person, for example, was set free before schedule and was then a recidivist. That means he became criminal again. However, the yellow one, he purged. That means he was set free before schedule as well and behaved well, and he is a good candidate where you could say, hey, here we have done a good decision. Now you see this two-dimensional model, and the question is, using a support vector machine, is it possible to define who should go out or who we should let free and who should stay in the prison? And we are not talking about a bias with respect to people of color or male or something like that. We're simply talking about how to set this line. Now remember, if we have a support vector machine, we can only draw a straight line. We cannot make a curve. So of course, one example would be the following curve, line. We could go like this, which means we have at least one candidate, this one, who is on the wrong side, meaning he gets free, although he is a recidivist. And we have three others which do not get free, although they would be good candidates. The question now is how to choose this line. And there is, of course, different kind of strategies. You could define one kind of strategy, which is make the less amount of faults. So only the minimum number of people should be on the wrong side, so to say. You could have a, let's say, pessimistic view and say none of these recidivists should be get free. Then you would maybe draw a line like that. So the minimal number of faults is getting higher. However, there is no one getting free who is not to be let free. You could draw another line, for example, like this, to say we believe in the good and we still do not want to punish somebody simply because others do not behave well. Then we would maybe draw this line and say on this side all should be free, on this side all should stay in prison. The thing here is that to draw this line is basically a configuration decision. And this has to be clear once you have made this neural network, once you do this kind of measurements and decisions later on, that there is this kind of arbitrary decisions. When you do nowadays, for example, a corona test, basically it's the same thing. You simply, in the end, simplified again, count the number of viruses. And starting with a certain amount of viruses, let's say 10 out of whatsoever, you say somebody is infected, and with 9 he or she is not infected. And this number 9 or 10, with the borderline basically, is defined, yes, with some thinking in mind, but it's in the end arbitrary. You could define other values as well. And this has a very high influence of the behavior of your system. So the problem is, it should be really clear how the decision is made, what kind of arbitrary decisions are taken in, and what kind of values are behind this kind of decisions. Are you more a positive person? Are you more optimistic or pessimistic person? Are you more focusing on secureness rather on liberty? So these kind of things go into this kind of decisions. And of course, these have to be discussed if we talk about ethical decisions with respect to these kind of situations. And again, these kind of algorithms are nowadays used to make these decisions. So yes, these kind of decisions have to be questions, not in the way we should not do it like that, more in the way how do we come to this kind of decision? How do we come to configuring a system like it is today? Ethics are currently only given little consideration when it comes to the development of IT. And it's basically the same in the digital transformation when we more focus on the application of IT, when IT is the enabling part, but we do not really look on ethics. We're looking more on organizational issues and on value added. Why that? Historically, in the 80s, we have focused much more on functionality. So when I did my thesis, it was more, we had to do an implementation of a program, and if it runs fine, and if it does the functions it should do, basically you have got your thesis. Later on, quality came into a game. Things like the performance of the software, the usability, and so on and so on. And in the 90s, we found out, hey, it's not sufficient to have simply running software. If there is no added value, if you cannot make money with it, then it's not worth to invest in it. Yeah? So money and budgets became an issue. And in the 2000s, we had software which had a cool functionality, which was working very fine, which really created money, but did not follow the rules, did not follow the laws. For example, data privacy. So this is now an issue which is no longer only under consideration, but is taken as an issue. However, ethics, that's an issue which popped up only in the last years. By the way, what are ethical goals? One could be fairness. There's lots of it, but let's just focus on this one. Fairness means that software should not discriminate. For example, it should not favor white people in contrast to people of color. It should not favor male over female, and so on and so on. Another one would be trustworthiness. Yeah, you should be able to trust that the software is really doing what it's intended to do. There is no Trojan horse inside. So these are examples for ethical goals. Of course, there is much more. And how could ethics be included in the software development process or in the digital transformation? You could really go back and the philosophy. Yeah, and take, for example, approaches like the categorical imperative or Kantian imperative, which actually means an action should only be right for anyone if it is right for everyone. Or take Descartes' rule of change. An action is only right in an ethical scene if you can do it again and again, if you can perform it repeatedly. So if you say, I have a problem with my garbage, I simply put it on the street, it doesn't matter because it's just a little bit of garbage, but you can't do it again and again and again because then there is too much garbage. Yeah? Then, according to Descartes' rule, you should not do it even one time. You could go for the utilitarian principle, which means if you do an action, you simply calculate all the impacts, all the possible and all these achievements, positive and negative achievements. And then you draw a line and sum it up, and you should only take an action if you achieve a high benefit. However, this is a little bit tricky, because if, for example, many people have a high achievement, or at least a little bit a benefit, because one person is suffering, maybe it's not that ethic. Here maybe the principle of risk avoidance should be taken. An action only makes sense, according to this principle, if it causes the least possible harm. So we do not focus on benefit, we do focus on harm, and the harm should be minimized. The benefit should not be maximized, but the harm should be minimized. These kind of principles of ethics on a very high abstract level are easy to understand, but in practice they do not help too much. So there are some more practical approaches. For example, there is a new standard from the last year, I think, 2021, IEEE 7000, which defines the value-based engineering. And here 10 principles have been defined. Just take a look on this link. 10 principles have been defined which should be followed to gain ethical software. Which gains software which is grounded on ethical values. Another approach is value-sensitive design, which already has been proven in several projects that it is able to incorporate ethical values into the design. In the following video, I will explain another one, which is the risk matrix and the derived regulatory classes developed by Katharina Zweig. Let's have a look on the risk matrix, which has been designed to evaluate algorithmic decision systems, for example neural networks or machine learning networks, which are fed with data and then make a decision in whatever respect. The matrix is two-dimensional, and in the x-axis you do have the damage. So if you make a decision, for example, let's take this example of the credit scoring. You are asked for a credit, you don't get it because the algorithm argues you're not creditworthy, then the damage is somehow medium. It's more than cumbersome because maybe you need the money. However, you're not getting killed, you're not getting ill, so it's somehow medium. The other dimension is the alternative dimension. So the question is, could you go to another whatever vendor and asked for another credit? Or is there a monopoly? Yeah, so when it comes to the credit scoring, again, you're somewhere in the middle. If the one bank doesn't offer you a credit, you can go to another bank. So let's get through and have a look on a few examples. So if you have a simple recommendation system like Amazon's, you know this customer who bought this, bought that well, and you might get recommendations which simply do not fit. Then it's simply cumbersome. However, you do not risk your life. Yeah, so the impact, the damage is quite small, and you have the opportunity to go somewhere else. You do not depend on Amazon. You can go into another job. Take, for example, Facebook recommendations. Yeah, here probably the damage is still medium. You get, for example, some recommendations, some information which is not correct. However, Facebook is really going to be a monopoly for many people. Think about these elections in the US a few years ago where Trump has won. Think about filtering applications, this system by Amazon. Yeah? So if you're filtered out, you maybe have a job to apply for another job in, you have the alternative to apply for another job in another company. So yes, it's already not that nice. If maybe it's worse compared to not getting a credit, not to get a job, but at least there's alternatives. However, if you have an automatic evaluation of employees, you still are within one company, then the company has a somehow monopoly-like situation, because usually people do not have many companies where they're employed in. It really becomes problematic if you go, for example, on an economic scale. When you know this China citizen score, where each and every person is evaluated by this China citizen score. Then you cannot simply argue as a Chinese citizen, hey, I would like to be evaluated by another system. The state does it for you, and the impact can be relatively high. Maybe you're not allowed to travel anymore, and so on and so on. And it even becomes worse when you think about lethal autonomous weapon. If somehow, let's say, a weapon is shooting at you, you are not in a position to decide, I do not want to be shooted by this system, but by another system, which does maybe not identify me as an enemy or a terrorist. So here the effect, the damage is really high. It's quite big. It's your life. So what can we do with this matrix? Or what has Katharina Zweig done in here? She has entered some classes. You see these diagonals, and it's only qualitative at the, for the time being, but you can see here the damage is relatively low and you have alternatives, and the more you go in this direction, the damage gets higher and the less alternatives you have. So the systems become more and more critical. And so from a regulatory point of view, different means have or should be taken to allow or forbid the systems. How could it look like? So here we simply have once again these classes. You could think about 4 classes or 5 classes. It's just the idea is interesting. And having these classes, you could now come up with different requirements with respect to this risk class. So you could say, for example, when it comes to this class 0, there is no requirement at all. If people have alternatives and if the damage is relatively low, do whatever you like. However, if you have class 1, then some more measures should be taken, some more requirements should be taken. Let's now go it level by level. So what you can see here is the first level we talk about data. In the second we talk about quality measures. So how to decide how good, let's say, a certain system is. In the third level we talk about the learning algorithms, and in the last one we talk about the decision itself. And we always have 2 basically terms. The one is the more harder one to fulfill is the traceability, meaning you have to understand the data. You have to know what kind of, not only to know what kind of data is taken, but you have to be able to take this data by yourself and have a look into it. Or if you just declare what kind of data has been used. So, and here in this matrix, Katharina Zweig proposes the following. Let's say when it comes to class 1, it should be necessary to declare the quality measures. It should be important to declare the learning algorithms. For example, we take a support vector machine, and these are this way how we have configured it, and we specify how the decision is taken within our decision process. So what part actually the algorithmic decision is doing. Is it only an assistance system and an employee has then to deal with it, or is really the machine taking the decision and you have no chance to argue against it. In class 2, on top of these requirements, there is a declaration of training and input data and the traceability of quality measures. So you have to be able, the one who uses this machine has to be able to trace back the quality measures. In class 3, the requirements even get higher, and you see in class 4 there's no requirements added. Instead, what you can see here in class 3, the decisions have to be completely traceable, which means the data has to be traceable, the learning algorithm has to be traceable, the quality measures have to be traceable, and the decision as such is traceable. So you can, for example, understand if you do not get a credit, why do I do not get a credit? If this is not guaranteed, then these kind of systems should not be used, at least for class 3 items. And in class 4, Katharina Zweig is quite strict. These things should not be done by algorithms. So if you think about these lethal autonomous weapon, those should simply not be implemented. If we talk about war, then the decision to kill somebody should be taken by man, not by computer. As stated in the very beginning, ethical issues are not addressed at the moment, or we just start to address ethical issues. That means there is not much experience with it, there is no many frameworks or methods. However, the more we become powerful computers and if we get more and more interconnected IT and so on, we will face more and more ethical challenges. So we cannot hide away from it. Currently, these challenges are hardly considered in the development of IT nor in the digital transformation. However, a few approaches exist and they will become more and more important in the future. So do not say it's not important because it's not really working right now. During your lifetime, this will become an issue for your decisions with respect to IT. There's a few references. Sorry again, some of them are in German, but have a look, for example, on this standard and on these questions, these 10 questions for ethical design, or take a look on this information systems book, which is in English available as well. Good luck with this lecture. Good luck in the exam.